Hello everybody, welcome to the final section in Unit 1. We're going to be covering control structures, which spans chapters 4 and 5. And in this section we're going to be talking about the Boolean type in C++, and comparing that with integers, and we're going to talk about how to use Boolean expressions, and we're also going to cover type conversions and how to use assert statements, and we're going to cover the debugging mode again just to make sure you have a good handle on that, right? And then in chapter 5 we're going to cover loops, which you should have a handle on. Now, with the exception of the bool type, C++ control structures are identical to the control structures in Java, so this should be very similar to you, or familiar with you, excuse me. We're just going to recap it so that way you can make sure that you're refreshed on those structures. Of course, the learning objectives for this video, or for this section, is going to be make sure that you know how to evaluate Boolean expressions, make sure that you can write proper Boolean expressions in C++, and use our various control structures to form a program. As you know, control structures are the heart of any program. Like, if you didn't have them, you wouldn't have much of a program at all, right? And again, debugging is extremely important, so we're going to cover that again and make sure that you can debug your programs both using the assert function and the debugging mode of an IDE. So without further delay, let's go ahead and cover chapter 4, control structures. Now, earlier versions of C did not provide built-in data types for Boolean values. This was something that was added in C++. Previously, if you wanted to evaluate something to true or false, you would just use 1 or 0. But thankfully, somebody has added the Boolean type to C++, and so now we can actually use the true and plus values. Some things that you have to keep in mind, though, is that true is 1 and false is 0, right? And any non-zero value evaluates to true, okay? So if you have an expression like a string that is, contents is a name, and you try to do a Boolean expression on that, it is going to evaluate to true because it is non-zero value. 0 will evaluate to false because false is already stored as 0. So that's just a different take on the Boolean that's a little bit different from Java. Again, you'll have to notice that C uses the bool type right there, whereas Java uses actually the fully spelled out Boolean, right? So just remember that when you want a bool in C++, you have to use the bool type, not Boolean. Another thing that we need to cover is type conversion, and you should be familiar with this concept from Java. Type conversion is where we take one data type, say an integer, and convert it to another data type. Could be a char, could be a float, could be something else, right? And there's two different ways that we do type conversion. There's the implicit type conversion or type coercion, which is the compiler automatically does it for you, okay? And it will do this in the following order. Like, you can convert a bool to a char, and a char to a short, and a short to an int, so on and so forth. Remember that the bool is the narrowest data type, and the double is the widest data type, okay? And you can only go in that direction, okay? You can't implicitly convert a double to a float and a float to an int because you will lose precision. Okay, you can go up, but you can't go down. Okay, so in the following code, the true value is stored as 1, and so B will be promoted to a char value. Okay, and then we assign it to the value of C. We then implicitly store C's value as an integer into I, and then print it out. So let's walk through the code and see what's going to happen. Well, what does true equate to? Well, from what you remember, right, true should be equal to 1, right? And then when we cast 1 to a char, what is that going to equal? Well, I don't have the ASCII character of 1 in memory, so we're going to have to see, right? And then we're going to store C in I. Well, what's C? Well, C is 1, so integer I is going to be 1, right? So when we print it out, what is it going to look like? It's going to look like that, okay? That's because the smiley face guy right here is just Visual Studio's representation of the char value of 1. And if we were to look at what the actual ASCII value was, we can pull that up on a website, ASCIIcode.com, where there's plenty of other sites that have this listed, and we look at decimal 1, and its value is start of heading. Okay, obviously that doesn't have an actual character representation, so that's why Visual Studio puts in our lovely smiley face. So what happens if you need to convert to a more narrower type? Okay, well then we have to do an explicit cast. Okay, and so here is the syntax for doing that. It's the type casting operator. You can see we have static type right here, or static cast, and then we're going to specify the type right here. Okay, this is the type, and then we have our expression of what we actually want to cast. Okay, so what does that actually look like in code? That's your next question, right? Well, here's an example of that. Here we have a type of double called D, and its value is 4.5, and we are casting it to a integer. Okay, now this is assuming that I has already been declared, of course, right? And so if we were to run that, we would see that I is now going to be equal to 4 because it just truncates the decimal part, right? Now keep in mind that the value of D does not change. We are not changing what is stored in D. It is still a double, it is still 4.5, right? All we are doing is we're going to say, hey, compiler, cast this value to an integer. We don't care about the decimal point. We know what we're doing, and store it in I, and then it's going to print it out. Okay. Now, there's also a function to do this from C, which does work in C++ as well, and that is the actual, there's a expression or a function that does this for us. So here we can see that we have the integer D, or integer when we're passing in the parameter D and storing. It's the same, but with C++, we're going to want to use the static cast int, not the function. And one reason why you want to use this type of cast right here over this type is because the C++ style cast, the static cast, is actually checked by the compiler. Okay, these are not checked by the compiler and can give you errors at runtime, whereas this will be caught when you compile it, so it's much easier to debug. Okay. Another point that you need to be refreshed on is that we do not use the equality operator, that's the double equals, on floating point numbers. Okay, so what's an example of that? Well, let's take a look. So here you can see we have a double, D is equal to 0.1, and we're saying if 3 times 0.01 is equal to 0.3, print equal. Otherwise, print not equal. So why do we not do this? Well, that's because, again, floating point numbers are not as cut and dry as what you think they are in normal life. So because of the way that they are actually processed in the computer, 0.1 right here could actually be 0.10000000001. Okay? So if we do D times 3, we're going to get 0.300000003, that is clearly not equal to 0.300, or 0.3, excuse me. So we do not use the equals equals on floating point numbers. You're like, well, how do I check to see if something is equal to that? Okay, so here's how we're going to do that. We are going to check that the absolute value of these two values right here is less than some delta. Okay, and this is basically, you're specifying it to some level of precision. So you want to say, hey, I want to make sure that the difference between my d times 3 minus this value, the things that we want to compare, is less than some delta. So here we're saying, hey, we're giving it up to 5 decimal points. If it's within that precision, so say it's 0.000001, we're going to call it good. But if it's 3.2, guess what? That is not going to be less than 0.0001, and so therefore it's going to fail. Okay, so this right here is how you check for equality with floating point numbers. And this is going to come up, and you're going to make this mistake somewhere in your code somewhere, and you're going to spend hours troubleshooting it, and because you're going to forget about this lesson right here, that we don't use equality on floating point numbers. Okay, so I'm hitting it a bunch of times to make sure that I kind of get it into your skull that we do not use equality operators on floating point numbers. And that goes for just about any language out there. Another common mistake that people make is they try to do comparisons or evaluations like this. They say, oh, well, if 0 is less than number and that is less than or equal to 10, right? It doesn't work that way. Okay? What you have to do is you have to say, if 0 is less than or equal to my number and my number is less than or equal to 10. All right? This is going to give you the behavior that you want. Likewise, that goes the same for our Boolean operations, our ands and ors and whatnot, right? Here we have char is equal to A, right? If C is equal to C or B, okay, don't do that. This is bad, right? Here's the correct way to do it. If C is equal to the character C or C is equal to B, then do something, okay? So again, that's just a very common mistake that people make. You should probably know it by now not to do it, but again, I just wanted to touch on it just to make sure. So if you remember from our last chapter, we talked about reading files in, reading data in from a file, and this is an example of where we can use a Boolean expression right here to be used as a stop condition for our while loop. And again, we'll cover while loops in a little bit, but we are trying to extract some data type from our stream. In this case, it's a file stream, and the success of this operation will evaluate to true or false. So if there's more things that this can extract, then it will be true and we'll process it and continue to loop. If we're at the end of the stream or it returns an error for some reason, then it will resolve to false. Okay, the stream extraction operator will return false, and we'll know that, hey, there's a failure, so we must be done, or some other thing, so we're going to stop processing it. Okay, I'm covering it again because there's a good chance that your homework will probably have something like this in it, possibly. So you should probably understand what's going on here with this stream extraction operator and how we're using its return as a Boolean expression to terminate our while loop. So what you can see here is that the previous way that I showed you is just a simplified version of doing this, right? This is going to be resolved to a true or false. So while our last input succeeded, right, do some processing and then read in the next thing. While that's true, process it, okay? So this right here, what we had before, is just a cleaner version of what we had previously. Or not previously, above it right here. Okay, so this is the style that you would want to use because it's just cleaner. Additionally, you can use it if you have multiple things that you want to process. So you can see here we're saying while we can extract the string, age, and height from a file, go ahead and read those things. Okay, so the nice thing about this is it can handle faulty records, and it can also handle corrupted files. So let's look at a demo of this in code so you can see how it works. When we look at the code, you can see that I've modified the while loop to extract multiple things from our in file. A string followed by an age. So it would follow that we need to modify our data file to include those things. So if I look at the data file, you can see that I've added ages to our people. Okay, when we run our program here, we'll just do a quick demo. And you can see it executes without a problem. It prints out the person and the age, reads everything in just fine. Okay, what if our data file is corrupted? What if maybe Karen is missing an age and instead has some string there? Okay, what will happen? Well, let's find out. When we run our program, you will see that it stops after Larry. You can see Tom, Mary, Larry, right? And if we look at our data again, you can see Tom, Mary, Larry. So it read in up to Larry and then it stopped on Karen. Note that it didn't skip Karen. It didn't pick up, after Karen and print out Jack and April. It just terminated the program. That's because our extraction operator, since age was not able to extract an integer as the next token in our in file, it set in file equal to false, and so while is checking the status of in file, and in file is set to false, so it's going to exit the loop and then terminate. Okay, this also works if it was just missing. So say Karen had a blank there. All right, so let's save it and run it, and you'll see the same thing happened. Okay, what if we fix it and we say, oh, Karen, you know what, she's 25, and what if for some reason there was no white space in there? Let's test this out. So here you can see that we got Tom, Mary, and Larry, and Karen now, but we lost Jack, okay, because it was unable to read the integer number for Jack. So what if for some reason we had two of them? Well, I'll put in 56 twice. What do you think is going to happen? Now you can see it read Jack 56 as one entire string, right? And 56 as its own integer. So you got to be careful on how you function, how you process your data and how you handle errors. But this is a good, safe way to make sure that if it can't read anything, whoops, down here, if you can't read it correctly, it will terminate the program gracefully. Okay, and there's some other things we could do here. We could say, well, what if we had them all like this? Let's fix this. All right, this is all on one line. Let's go ahead and run it and see. So you can see that work. The extraction operator is smart enough to know that Mary followed after 32 is a new data type, and so it stopped at the M and said, oh, 32, that's an integer, sweet. And then it picked up after that and said, oh, Mary's our next string. Okay, cool. So this works, but we can't do something like this where we have Tom 32, Mary 19, because it's going to read Tom 32 as one entire string. Okay, so that's it, running it in a nutshell. Again, the in file gets set to be true or false based on the status of the last read operation. Notice that it didn't print out the string part of that line because it has to pull all of these variables from the file before it will execute the loop. So if any one part of that line was wrong, it will still read false and it will skip it. Now, we got a little ahead of ourselves talking about the while loop before we actually brought it up in the lecture, but we can now proceed to talking about the different types of control structures, whether it's a sequence, selection, or repetition. And again, a sequence is merely just executing one line after the next, after the next, after the next. Okay, so that's pretty self-explanatory. We don't really need to go into any more detail there. Selection is our if statements. If this is true, do this, otherwise do that. Okay, we're going to cover that just real briefly. And then again, repetition are our loops, our while, our do, for loops, etc. So let's take a look at these a little bit more closely. Our selection statements are virtually identical to what they are in Java. We have the one-way selection, which is just an if statement. If something is true, execute it. Otherwise, don't execute it and continue on with our sequential execution of whatever comes after the if loop, right? We also have our two-way selection, which is our if or else statement, which says you're going to go one of two ways, right? You've reached a fork in the road. If this thing is true, we're going to go do this thing to the left, or if it's false, then we're going to go do this thing to the right, right? And again, this is exactly identical to Java, right? And then in our multi-way selection is we have a number of options available to us, right? If this first thing is true, do this. Otherwise, check some other condition. If that thing is true, do that. Otherwise, check this third condition, and so on and so forth. And this is called a multi-way selection. Now, another type of multi-way selection, of course, is our switch statements. And again, this is identical to Java. Okay? This is a cleaner way to write a multi-selection statement that is evaluated on the basis of a single condition. Okay? And with C, like Java, it needs to evaluate to an int, char, or a bool. Okay? So you can have, if it's a bool expression, then you can only have two cases, a true and false, or a 0 and a 1, right? But with an integer, you can have any number of different cases that you want to check for, okay? And it's only going to execute one of them. It's not going to execute all of them unless you're missing a break, right? That is important to note, that if you are missing a break statement, right? I'm going to get my pen out. Okay, if we got rid of this break statement right here, when we did case 1, when it was complete, it would fall through to the next statement and execute case 2. At which point, when it was done, it would reach the break and leave the switch expression. So it's important to remember that you include your break statements after each case. Otherwise, you're going to have unintended behavior in your program. Okay, so remember that your expression right here is what needs to evaluate to an int, char, or bool. Okay, now you can have this predefined in some assignment statement before the switch, right? You can say char a equals blah, or int b equals something else, right? And then evaluate that variable here. Just say switch b, right? If we had int b equals 37, right? Then we could say, instead of expression right here, we could just have the variable b, right? And then we would have, obviously, case n, this would be case 37, execute those things, right? So that's just an example of how you can use a switch statement. Again, just refresher, you should already be aware of this. Let's talk about debugging a little bit more, just to make sure that you guys are getting better with it. If your program compile, but it doesn't work correctly all or some of the times, then you have a logic error. Okay, it's not a what we call runtime error. It's your code is doing what you told it to do, but there was something that was flawed in your thinking. Okay, that's not necessarily a bad thing. It happens to everybody. Okay, so when this happens, we need to trace the execution of our program to see what is going on. Maybe your algorithm in your brain was right, but you just coded something wrong. And so the computer, of course, is only going to do what you tell it to do. And if you don't understand correctly the syntax of the language or some other component, you might have messed something up that still works syntactically with the compiler, but it throws off your program execution. Okay, so how do we trace the program? Well, the first and foremost thing that everybody goes to is adding temporary print statements, and this is kind of very much the novice approach to debugging your program. You print out, hey, what's going on here, and you print out the variable so you can see it. Okay. Another way is to use the assert statements that we're going to cover, and that is to you add there. It's almost like little breakpoints into your code that says if this condition doesn't hold true, you terminate the program, right? So if you're looking for some kind of input and you're saying this variable should be greater than 0, you assert that that variable is greater than 0, and if it's not, when you execute your program, it will terminate automatically, and it'll tell you, hey, this failed because this value was not within the bounds of the assert. And so that is another debugging technique that you can use, so that way you can find certain conditions that you don't want to happen. And then finally, of course, and we've covered this a little bit, is using the debugging mode of your IDE. And the basics of debugging are very easy to use. You just have to get comfortable using it. Here's how you use the assert function. Okay, first you need to include the CAssert header. All right, so that is first and foremost. Now this define and debug, this is what they call a macro that the precompiler will use to turn off your debug asserts. Okay, so this is something that you want to enable when you want to disable your asserts, and so we put it in here so that way you can easily turn them on and off as like a toggle switch for when you want to use your asserts. So when you want the asserts in your program and you're testing it and you're debugging it, you want to have this commented out. Okay, right there. You don't want to have ndebug defined. After you've tested your program and your program is working fine, you want to comment it out so your program does not run all of your asserts, because it can add runtime and it can make your program run longer. Okay, so how do you actually use the asserts? So here we've got this program, right, and it's going to do some stuff, right? We've got two integers, an hour difference and a minute difference, okay? And we want to add some code to it, but we're not going to do that now, right? And at the end of processing, we want to make sure that the hour difference is greater than or equal to 0, and the minimum or the minute difference is greater than or equal to 0. If it is not, it will terminate right there, telling you that it threw an assert. Okay, if our difference is, say, negative, right, it's going to terminate the program. So that's how you use the assert function included in the CAssert library that you include, or in the header file. When the assert gets thrown, when it happens, okay, two things happen. First, it halts the program, and then it's going to identify the expression where the assertion failed, the name of the file containing the source code, and the line number. Okay, so it's going to give you an error statement that gets printed out. And again, once you fix your program, so you go back and you edit your code, and your program's working good, then you can just uncomment the define and debug, and it will not check the asserts when your program executes. Let's take a look at this running in Visual Studio so you can get a better feel for what's going on. So if I pull up my Visual Studio, here you can see that I have that same code that was listed. I made some minor changes to it where I just included this output to output the difference, okay? Or just the addition of these two together. If we run the program, okay, you will see that it printed out hour difference plus minute difference equals 0 and an end line. Awesome, okay? We can change this to say, hey, you know what, you're 30. We run it again, and bada boom, bada bing, you see that it prints out 30. Okay, awesome. What happens if I say, hey, you know what, you're negative 30, right? This should now cause the assert to fail, right? Whoops. Let's make sure that we're commented out. this right here, this -30, should cause this part of the assert to fail, because remember, this is an AND condition, so we're saying that both of these conditions have to be true. So if we run the debugger, right, you can see right there, debug error, program, blah, 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 abort has been called, right? Okay. And it will tell us that it failed. All right. And it tells you right here at line 15. Okay, so we can see exactly what assert caused the failure. Right. So run it again for giggles, and you can say retry, and it tells you right there. If you do retry, it says, hey, an exception was thrown. It triggered a breakpoint. Okay. So that's all there is to asserts. Now, if we uncomment this out, like I talked about, and now this ndebug macro, that's what that's called, will get the preprocessor will expand this macro to do different things to turn off these assert functions. Okay, so all you have to know is that when you run your program, you can see now that the program executes just fine, because all we're doing is printing out the values, right? There's no actual logic that's really involved, but it's not executing this statement at all. All right, it's just totally skipping it. So if we comment out this ndebug, you'll see that we get our assertion failure again. Okay, so that's the assert, and that's how you can use it inside of your program. You use it to check for conditions that you know shouldn't happen. All right. And as I've already stated and already shown you, the debugging mode of an IDE is another tool that you can use and it's a very powerful tool to help you figure out your program behavior. Right. And if you're using a different IDE than Visual Studio, you're going to need to look up how you do debugging in that particular IDE. But they're all very, very similar. To start debugging mode, now I showed you one way to do it where you set breakpoints earlier, right? But this is another way to do it, and this is with Visual Studio 13, but it's the same in 17, but it's the same in 19. Is if you right-click on your code anywhere, you can click on Run to Cursor, and it will enter automatically into debug mode and set a breakpoint where your cursor's at. Okay? So, and then it will give you the controls up at the top, right? So let's take a look at that, how that looks in the IDE. So here you can see our program, and I switched back to our file input program. And again, we're just reading in a file, and then we're going to start processing it. So say I wanted to open the file, make sure everything was okay, and I wanted to stop right here. All right, all I got to do is right click, and I can click Run to Cursor. And it will automatically open into debug mode, run the program, and stop right here. Now keep in mind that my cursor was here, so it ran up to the next line of where my cursor was at. So it stopped at line 27, but here you can see all of the same stuff, things that we had before, our different variables. We've got our age, we got our in-file object, and we got our string. Okay, and so now what we can do is we can use our controls that we talked about earlier. Okay, they're all up here, and we can step into or we can step over. So if I step over, it's going to go line by line through our while loop and process all of those items in our while loop, right? And you can see here our output is slowly getting built. Okay, and we can keep going through. If I hit it a couple more times, you can see that we're gonna, whoops, wrong thing. You can see that we now have added Karen, set through it again. Okay, we should now have the next one, which is going to be Jack. Okay, so Jack is 56. So you can see that we can execute using our debug, right? We can also step out of, which will jump out of the while loop and finish going through the program. Now you can also set multiple breakpoints and have your debug stop at those breakpoints. So let's go ahead and set a couple here, here, and here, and we're going to run our debugger, and you can see that it stopped here, and we're like, cool, all right, and we can continue, and you can see that it skipped to this breakpoint. Why didn't it touch this breakpoint? Well, that's because this breakpoint is only, this line is only reached if we had a failure in our file. Okay? So it's going to completely skip that because the program never went through these lines. Okay? And of course we can click and continue, and it's going to keep executing the while loop, right? So if we want to jump over that, we can just say, we can just clear the breakpoint and then just say continue, and it'll terminate the program. And additionally, there's some additional resources that you can review. This is actually a really good video. A guy doing a series on C++ coding, not a bad one to subscribe to and watch. But he covers the debugger and goes into some more advanced features that you really don't need to use at this stage of your education. But nonetheless, it's a good one to watch if you just need a second opinion on something. Additionally, I recommend reviewing the first link, which takes you to this Microsoft site that gives you an overview of the debugging a simple Hello World program, and it walks you through it. And again, it shows some of the additional features that you can see in the other video that I pointed out, but it talks about standalone debuggers versus integrated debuggers, and all of your stepping intos and stepping overs and modifying variables and looking at the call stack. So again, another resource, I highly recommend going through it and practicing it, so that way when it comes time to troubleshooting your own programs, you have all of the tools at your disposal to be as efficient and effective as you can be, because you are going to need the help. So now let's turn our attention to loops, which again, they're the same as they are in Java. We have our standard for loop, right, where we have our initial set, our initialization function. We also have our stop condition, and then we have our incrementing function right here. So, while we're going to start with I equal to 0, while I is less than 10, we're going to increment I at the end of the loop of the body, right? And here's our standard while loop. Again, it's the same thing as this code right here, right? Except for it's in a while loop format. Here we're declaring variable I to be equal to 0, while I is less than 10. We're going to do some stuff, and then we're going to increment I. And again, here it is in a do loop format, where we know that we are going to execute this body of the loop at least once, because we're checking it at the end of the loop instead of checking it at the beginning of the loop. Okay, so again, this is the exact same as Java. We're not going to be going into any great detail beyond that. You should be familiar with it at this point. But nonetheless, we'll take a look at a quick example here. So given this code, right, what happens? What's going on here? Let's walk through the code just to make sure you're on the same page. First, we have obviously our main function right here, right? Whoops. I was trying to get my laser pointer. Right, we got our main function right here, and we're declaring some variables, and we're sending a message out to the user. We're saying, hey, press Control-Z to end input, right? And then on our while loop, we're reading in a number, okay? So if you recall from our previous slides when we were talking about our file streams returning true or false when our extraction operator was successful or not, this is the same situation, except for instead of a file stream, we're using the standard input stream, and we're trying to read a number for the console. And so if we read a number, in this case an integer, right, we're going to add it to our sum, right? And if you remember this operator, this is the same as saying sum equals sum plus num, right? It's taking this value and adding it to what's already in sum, right? And then it's going to keep doing that while the user keeps inputting a number. Remember, we're going to pause every time for the user to enter something through the console. And it's going to keep doing this until you put in something that's not a number. In this case, the Control-Z command is going to get read by cin, and it's going to say, oh, that's not a number, and it's going to quit, and then it's going to output the sum of all those values. And then that's when we get what already popped up is that, right? So we're entering 20, we're entering 40, and then we're hitting in Control Z. And then once it's all done, it's going to print out our sum, which again is just 60. Okay. And of course, we have our break statements, which we already partially covered, talking about how they're used to break out of a switch structure, but we can also use them to terminate early from a loop. Okay, so here you can see another example where it's the same thing, and we're saying, hey, if we're checking to see if number is a positive value, right? And if it is a negative value, then we want to exit the loop. And so here we're sending out an error message. We're saying, hey, we're stopping on negative values. Otherwise, we keep processing, right? And so that's going to give us an output that looks like this. Here we're putting in 10, 20, 10, and negative 10, and then it's stopping on the negative value and giving us what we had already entered. Conversely to that, we have continue, which is used in loops to skip over a section of the loop and to continue our loop execution at the next iteration. Okay, so it's different. We're not breaking out of the loop entirely. We're just breaking out of the one iteration, and then we're processing it further. So we can look at that as something like this, right? Here we're saying, hey, if number is a negative value, instead of just stopping on the negative value, we want to skip it. And so we put in continue at the last line of that if statement, which is going to cause us to skip over this part down here. It's going to say continue, and it's going to cause us to jump out and then go back and execute again, right? So it gives the user an opportunity to enter another number and not worry about the junk negative value that they put in. And you can see the program execution gives us something like this, where we can put in 10, 20, negative 10. It says, oh, we're skipping. We put in negative 50. We're skipping. We put in 10. And so our sum, you can see, is 10 plus 20 plus 10 is 40. So in summary, we talked about ints versus bools a little bit. We talked about how to compare Boolean expressions. We talked about the assignment versus the equality operator. And the book goes into much more detail. Again, these videos do not replace the need for you to read your book. There's just additional ways for you to process the knowledge that you're getting from the book. We talked about type conversions using explicit type static cast operator, where the type is in the angle brackets, right? We also talked about the implicit casting, which you can do when you're going from a narrow type to a wider type. So you can go from Boolean to an int, but you can't implicitly go from an int to a Boolean because of loss of precision. We also talked about debugging and how you can use print statements, how you can use assert statements, and the IDE debugger itself. Okay, and then we talked about the different program control structures. As again, just a refresher, they're very similar to Java. We talked about our selection statements, our if statements, and our switch statements, and then we also talked about our repetition statements, which are the different loop structures such as for, while, and do. Okay, so that's it for Unit 1. Again, we're moving through a lot of stuff very quickly. This was like 4 weeks worth of Java class, and you get it all compressed into 1 week because you should know it already. We're just looking at the differences in syntax between Java and C++.